Welcome to the tinyML Asia 2020. I'm Hye-jun Yu. I'm a professor of electrical engineering at KAIST Korea and chair of today's session, the plenary session and session number 1, hardware session. And it is my pleasure to be on the technical program committee for the tinyML Asia. Let me introduce the general chair and also the plenary speaker of tinyML Asia 2020, Professor Wei. Professor Shaojun WEI is the director of the Institute of Microelectronics at Tsinghua University, and his plenary presentation is titled The Road to Innovation for AI Chips in China. Professor Wei received a master's degree in engineering from Tsinghua University, Beijing, and doctor degree in applied science in 1991 from Faculty Polytechnique du Mans, Belgium. And then he became an assistant professor and research fellow. Dr. Wei returned to China in 1995, working for Datang Telecom Technology as president and CEO. He founded and ran Datang Microelectronics Technology. Later, he became the CTO of Datang Telecom Industry Group. Dr. Wei is now the Dean of the Department of Micro and Nano Electronics, Director of the Institute of Microelectronics, Tsinghua University, and Adjunct Professor of Peking University. Dr. Wei is the Vice President of Chinese Semiconductor Industry Association, President of Versailles Fabless Chapter, CSIA. He is the Fellow of CIE and Fellow of IEEE. Okay, please.
Good morning. Thank you so much for giving me this chance for presenting the innovation of AI chip in China. Here's my content of presentation. The first, let me give you an overview. Artificial intelligence is the mantra of the current era. As a materials carrier of intelligence innovation, AI chip constitute an essential building block in the development of AI technologies and applications. Among the three factors of AI development, the development of internet technology brings massive data. In recent years, the development of deep learning technology makes the algorithm more and more mature. So AI chip becomes the key and the battleground of AI, according to CCID, the consulting company in China. The scale of China's AI chip market will remain a growth rate of more than 50% in the next 3 years, and a further increase to 30.5 billion RMB in 2021. According to many factors, such as the physical limits of silicon transistor density and the limitation of the heat dissipation power consumption, the computational power divided brought by Moore's law for chip development is disappearing. However, AI computing power demands has increased over 300,000 times in 5 years since 2012. According to a report released by OpenAI. Moreover, Michael Jordan said, what we are doing today is not really artificial intelligence. It's just the use of technology to enhance one aspect of intelligence. In the future, different AI stage has different requirements for AI chips. Therefore, further development of AI needs innovation of AI chips technology. Since May 2017, new products of various AI chip manufacturers around the world have been released in competition. After several years of development, the division of label in each link is gradually obvious. The application sense of AI chip is no longer limited to the cloud. The products deployed on terminals such as smartphone, security camera, and automatic driving vehicle are becoming more and more abundant In addition to the pursuit of performance improvement, AI chips are gradually focusing on the optimization of special scenarios. Now, let's have a look on the classification of AI chip. According to development location, AI chip can be deployed in data center, mobile phone, security cameras, and automobile terminals, etc. According to the task undertaking, it can be divided into training chip and inference chip. At present, the training chip is generally deployed in the cloud. The inference chip is divided into mobile phone AI chip, security AI chip, and automobile AI chip. The market scale of cloud training chip will reach $17.2 billion in 2022, with a compound average growth rate to 54%. The size of the chip market will reach $7.2 billion in 2022, with a growth rate 84%. The size of the edge inference chip market for smartphone will reach $3.8 billion in 2022, with CAGR equals to 59%. The market size of edge inference chip for security camera will reach $1.8 billion in 2022, with CAGR 41%. The market size of the edge inference chip for autopilot will reach $5.2 billion in 2022. The CAGR will reach 44%. Among cloud training chip, NVIDIA's GPU plus CUDA computing platform is the most mature scheme. There are also the third-party heterogeneous computing platform such as OpenCL plus AMD GPU or OpenCL plus Intel/Xilinx FPGA. The third solution are self-developed by cloud computing service provider such as Google's TPU. Judging from the market competition pattern of whole cloud training chip, NVIDIA GPU has obvious advantages. Compared with training chip, the inference chip consider more comprehensive factors: unit power consumption, computing power, delay, cost, and so on. GPU is also used to accelerate the initial inference, but due to the particularity of the application scenario, the optimization based on the specific neural network algorithm will bring higher efficiency, and the performance of FPGA/ASIC may be more prominent. In addition to NVIDIA, Google, Xilinx, Altera, and other traditional chip manufacturers involved in the cloud inference chip, startups such as Krok also joined the competition. In Chinese companies, Cambrian and Bitcontinental are also active in cloud chip business. Since 2017, Apple, HiSilicon, Qualcomm, MediaTek, and other major chip manufacturers have successfully released a new generation of chips supporting AI accelerating function. And the AI chips are gradually infiltrating into mid-range products. Due to the limited space of a mobile phone, it's difficult for independent AI chip to be adopted by mobile phone manufacturers. Enterprises with first-mover advantage in AI-accelerated chip design capability, such as Complicant, generally cut in through IP authorizations. The front-end camera is equipped with terminal inference chip, which can structure the video data in real time. The edge computing solution of cloud plus edge is gradually penetrating. It's estimated that the market size of the inference chip applying security camera will increase to $1.8 billion in 2022 with CAGR to 41%. If we want to realize a real automatic driving of the vehicle, 3 stages are necessary: perception, modeling, and decision making. Each stage needs terminal inference chip. As shown in the figure, both the obstacle avoidance planning and environment awareness are the main application scenarios of AI in inference chip. The stronger demand for automotive semiconductor has already made the supply side capability and capacity tight. And the demands for inference chip for automatic driving is also expected to achieve rapid growth in the next 5 years. It's expected that its market size to grow from $850 million in 2017 to $5.2 billion in 2022. That is, the CAGR will be 44%. By technology roadmap, AI chip include deep neural network processor and neuromorphic chip. DNN processor can be classified into instruction set processor, data flow processor, computing memory processor, and the reconfigurable neural network processor. Now let's talk a little bit AI chip in China. It's just in its infancy and the market is growing rapidly. The cooperation mode between the enterprises and the customers is still under exploration. Over 60 enterprises have entered the battle of AI chips. Traditional chip companies like HiSilicon and Unisoc, startups with outstanding performance such as Cambrian and Bitmain, Internet technology giants with application scenarios and data resources like Ali and Baidu enter the field of self-developed AI chips and are moving towards the direction of cloud edge integrated product line. Instruction set processor is kind of AI processor, which has a complete set of neural network instructions, and its calculation process is driven by instructions. In China, MLU series AI processor of Cambrian, DTU of Inflame are its representative works. Let's take an overview of Cambrian instructions. The basic operations are divided into high-dimensional tensor operation, vector operation, and arithmetic logic operation, which are processed by different calculation units. Second, the high-dimensional tensor computing unit can support convolutional operation and the full connection operation efficiently. The third, the vector computing components can support activation and other operations. And finally, the logic computing units can support branch, jump, and so on. Thus, the famous AI chip 电脑 and 大电脑 are both based on the Cambrian ISA. Dataflow Processor is a tensor processing structure with operation behavior determined by data scheduling. Its representative work in China including Kasia DNN processor of Korean and the Sticker of Tsinghua University. Kasia Architecture breaks through the limitation of instruction set, and the overall architecture is designed based on data flow mode. The data transmission and the calculation operation of each clock in the underlying hardware design can be accurately predicted so as to realize the accurate calculation of clock level. In the clock-level precision hardware system, Kasia Architecture further improves the utilization of computing power by overlapping data calculation and data transmission. Dynamic balance of computing power and the data stream bandwidth reuse. In addition, it also supports the dynamic reorganization of the water line through the data flow network, so as to support the computing needs of different algorithms and meet the general requirements of the computing platform. The Kasia chip, based on Kasia 3.0 architecture, was mass-produced on June 2020. Its resource utilization is up to 95.4%, and the peak performance reaches 10.9 trillion ops per second. The Syncr series AI chip systematically explored the possibility of using network sparsity and lower bit width representation to improve the energy efficiency of neural network inferences. Its 140.3 TOPS energy efficiency is in the leading position in the world. It has been selected in ISSCC several times and is the first ISCC article published in mainland China. In Syncr, automatic neural network sparsity detection circuits switched the processor between 9 modes for better energy efficiency. Multisparsity compatible converse PE array contains a multi-model. PE array contain a multi-mode memory and a set of associated PEs. The memory supports 3 modes for different sparsity neural networks. It is sparse mode reduces 90% memory access and 5% sparsity, and its dense mode avoid index overhead. Set of associated PEs support both dense and sparse operations and reduce 92% memory area comparing with Hutch memory banks. Its online turning PE for Sparse FCS provides adaptability to devices under change circumstance based on quantization center, updating scheme and CSC format backward propagation. It is accuracy the weight updating by 5 orders magnitude and the CSC scheme achieved 21.6 times speed up in back propagation. Computing in memory means that the logic circuit or processing unit is placed near the memory so that the data is closer to the operation unit. All computation is performed directly in the memory without data transmission. This is research work on RRAM based on computing in memory, which was published online in Nature by the Institute of Microelectronics of Tsinghua University on January 29, 2020. In this fully hardware implemented memory resistor, CNN, 8128 by 16 1T1R memory resistor array are integrated to improve parallel computing efficiency, a hybrid training method to adapt to device imperfections and improve the overall system performance. Experimentally, a 5-layer memory resist-based CN was built to perform means-10 image recognition and achieved a high accuracy of more than 96%. In addition to parallel convolutions using different kernels with shared inputs, replications of multiple identical kernels in memory resistor array was demonstrated for processing different inputs in parallel. The memory resistor-based CNN neuromorphic system has an energy efficiency more than 2 orders of magnitude greater than that of state-of-the-art graphic processing unit, Tesla V100 GPU, and is shown to be scalable to large networks such as residual neural networks. This research work on SRAM-based CIM published by Professor Yang Jun and Shi Longxing of National ASIC Engineering Center of Southeast University at the International Solid-State Circuit Conference in 2019. It blends feature and partial weight memory with a computing circuit together, like a sandwich that achieves significantly less data access. It also uses a reconfigurable analog computation engine based on pulse weight modulation that is small and flexible enough to be inserted into the memory. The figure shows the overall architecture of the sandwich RAM consisting of control block for configuration, a weight pre-processing unit to reduce weight complexity, and a post-processing unit including an accumulation memory. The system supports 2 modes, a conventional SRAM mode and a computing SRAM mode for convolutional operations. Sandwich RAM contains 28 by 112 processing blocks, a configurable pulse generator, and a pulse quantizer by replica cell. Each block comprises of 6 by 8 bit ATSRAM cells to store partial feature data, several shift registers for partial weight storage, and an analog compute unit sandwiched between the memory arrays. A pulse computation unit is shared between 6 features, and 1 feature is selected for computation at a time. After 1 calculation, the weight can be shifted from the next calculation, repeating as such until all convolution with the stored feature map are computed. The traditional in-memory computing architecture is inflexible as it only operates on a row-by-row or column-by-column mode. This results in low utilization when the future kernel size varies. Sandwich RAM can be reconfigured based on the network into the 3 modes, a large, medium, or small window mode for large, medium, or small kernels. It can perform convolution operations for different kernel size to increase sandwich RAM utilization. Depending on the configuration mode from the controller, an input 3D feature map and the weight kernel can be broken up into several 2D plans and this proceed into sandwich RAM. Sandwich RAM is fabricated in a 28 CMOS technology. The Diphoto Graph is shown here. It shows the computing differential nonlinearity, which is the accumulation result for 1 law under different voltage and temperature corners. The DNL is less than 0.5 LSB because the DSCVG dynamically adjusts the control voltage and the PQRC tracks global PT variation. The energy efficiency improved by more than 4 times based on the filtered weighted computation and the features aware computation. 119.7 TOPS per watt peak energy efficiency is achieved at 0.6 volts. when running AlexNet convolutional layer, sandwich RAM achieves energy efficiency of 46.6 TOPS per watt. The computing memory architecture of the CIM architecture of within MEM tech is NOR flash based. Reconfigurable architecture is a kind of special architecture which organizes computing resource with different granularity and different functions with special hardware structure. At the runtime, according to the characteristics of the data flow, the hardware resources are interconnected to form a relatively fixed computing path. When the algorithm and application are transformed, the different computing paths are reconfigured to perform different tasks. Syncr2 Chip is a series of high energy efficiency multi-model hybrid neural network computing chip developed by the Institute of Microelectronics, Tsinghua University. Based on the reconfigurable architecture and the circuit technology accumulated by the team, it breaks through the bottleneck of neural network computing and memory access, and has the outstanding advantage of high energy efficiency. In 2017, the energy efficiency of Syncr2 has been 3 orders of magnitude higher than the GPU widely used in deep learning. Its core architecture relies hardware dynamic reconfiguration in 3 levels: basic processing unit array, and core computing components. It's a general neural network computing platform, which can be widely used in robotic, UAV, intelligent car, smart home, security monitoring, and consumer electronics. Due to the huge storage overhead and the computing requirement of deep neural networks, power consumption has become a major obstacle to deploy AI everywhere. Syncr2 is a reconfigurable architecture that supports low-bit wide network and high energy efficiency computing, which is specially designed for the extremely low power consumption requirements of edge applications. 2 kinds of binary ternary convolution optimization calculation method and hardware architecture are designed in Syncr2 chips, which greatly reduce the complexity of the algorithm and effectively eliminates redundant computing. In addition, aiming at the problem of load imbalance caused by sparsity, a hierarchical balanced scheduling method is designed, which can effectively improve the resource utilization rate through 2-level task scheduling of hardware and software cooperation. Syncr2 chip is produced in 28nm process. Its power consumption is only 10 mW when it runs at 200 MHz. Syncr2 employs 16 SRAM CIM macros for binary recurrent neural networks computation. It's a novel digital computing memory mixed architecture that runs an output weight dual stationary data flow, reducing 85.7% memory accessing. It is multi-bit external SRAM computing in memory macros and the corresponding tinyML weight adaptation reduces 9.9% energy consumption in average. It is predictive earlier batch normalization and the binarized unit reduce at most 28.3% computation in RNN. Furthermore, It designed a unique weight kernel decomposition based on convolution computation method for CIM. UWKDC decomposes an actual weight kernel into multi-sparse bitmap. Each bitmap labels kernel positions with the same weight value as 1 and label positions with other weights as 0. So one standard convolution is decomposed into multiple sparse convolutions, and each convolution results is multiplied with one actual weight. In this way, the multiplication count is reduced, and the additional count is not changed. The advantages of UWKDC include 4 aspects. The first, it can support DNNs with arbitrary weight precision. Second, it can accelerate both linear and nonlinear quantized DNNs. The third, it can remove redundant computations. And finally, we can in advance speculate the value range of the next pulse to dynamically choose proper quantization frequency for minimizing quantization energy and error. The overall architecture has 3 features. The first is a closed-flitting based fast kernel decomposer to generate a bitmap. The second is a dual-mode complementary predictor to remove redundant computations. The third is a time-domain CIM with activation weight adaptation pulse quantizer to perform bitmap convolution. This is chip Diphoto Graph and summary. The chip is fabricated in 28nm technology, supports linear and nonlinear quantized DNNs with 1 to 8-bit weight precision. The table shows the comparison between the CIDRs. The energy efficiency of a previous work for nonlinear quantized DNN is computed by scaling the reported energy efficiency to that for linear quantized DNN with 8-bit activations and weights. Benefits from the proposed convolution method and architecture. This work achieved 1.37 to 11.3 times improvement of energy efficient. Neuromorphic chip is an analog data processor inspired by the biological brain. By implementing a set of integration of transformation operations, Change is able to support spike neural networks, biological dynamic neural networks, multi-layer perceptions, convolutional neural networks, recurrent neural networks, and so on. It builds unified neural network execution unit for ANN and SNN. And based on the coarse-grained reconfigurable technology, it supports the conversion of coding mode between AN and SNN, so as to realize heterogeneous neural network. Darwin 2 adopts a 55nm standard CMOS technology, and a single chip is composed of 576 cores. Each core supports 256 neurons, and the synapses are more than 10 million. Through system-level expansion, it can build 10 million-level neuron brain-like computing system. This is research achievement on neuron morphological devices. It's published on Nature by Liu Ming at the mission of Institute of Microelectronics, Chinese Academy of Science. They propose and experimentally demonstrate an artificial spiking afferent nerve based on highly reliable memory resist for the first time. the spike frequency of the afferent nerve is proportional to the stimuli intensity before encountering the high stimuli, and then starts to reduce the spiking frequency at an inflection point. Using this afferent nerve, they further built a power-free spiking receptor system with a passive piezoelectric devices as the tactile sensor. The experimental results indicate that the proposed afferent nerve is promising for constructing self-aware neural robotics in the future. Finally, I make a summary. AI chip in China is still in this infancy, and there's a huge space for innovation in scientific research and industrial application. It will initiate disruptive technology that can make the breakthrough the performance and energy efficiency bottleneck of traditional architecture. It will lead the continued breakthrough development of relevant basic technology fields at all levels of circuits, devices, and process materials, and to promote the overall development of science and technology. That's all my presentation. Thank you for your attention.
Thank you very much, Professor Wei. We would like to thank our sponsor again, who have made this event possible. Our primary sponsor, ARM, the software and hardware foundation for tinyML, and Edge Cortex with the dynamic neural accelerator architecture and co-exploration engine brings cloud-level performance to the edge. And Sixth Sense builds ultra-low power sensing and inference hardware for embedded mobile and edge devices. And thank our partner organizations, SHI as our conference partner, and all of our media partners. And you have found them all listed on our website, tinyml.org. Thank you for joining tinyML Asia 2020 with us today. We look forward to seeing you tomorrow.